So let's get into what this chain rule formally tells us to do. And there's a couple of ways that we'll write it. We'll write it one in Leibniz notation, and the other one we'll look at Newton and some of the actual function notation. And we'll kind of use both throughout the course, especially here in Unit 3. But what the chain rule says is if y is some function of u, and so y equals f of u, that's what that implies, if it's some function of u. So if this y equals function is a differentiable function, meaning I can take its derivative, and we would say of u, so whatever this function is, as long as I can take the derivative with respect to u, and let's say that u is some sort of function, we'll call it g of x. So in other words, you can almost kind of see the composition of functions happening here. Y is f of u, and I can take its derivative with respect to u, but u itself is actually this function g of x, and we would say that u is a differentiable function of x, meaning I can take its derivative with respect to x. Then, and now we'll build that composition of functions. Y equals f of g of x is itself a differentiable function, meaning I can take the derivative of this composition of functions. It's a differentiable function of x. And now we're going to state what the chain rule really is going to look like for you. That, remember, this is what Leibniz notation looks like. It literally means the derivative of y with respect to x, the rate of change of y with respect to x. So if I take the derivative of y, then what I get is the derivative of y, that outer function with respect to u, times the derivative of u, that inner function, with respect to x. And I'll kind of plainly state this here at the end, but one of the advantages to Leibniz notation is this dy du and du dx, they're not fractions per se, they represent something. This represents the rate of change with y with respect to u. This is the rate of change with u with respect to x, but your kind of algebraic instincts kick in and want to do this sort of cancellation here, and you get dy dx, and it's kind of one of the benefits of Leibniz notation that we'll talk a lot more about throughout the course of this year. But what this means is that if I want to take the derivative of y, this composition of functions, that I take the derivative of y with respect to u, and then I take the derivative of u and with respect to x and multiply it. If I look at this in function notation, it may be even more clear for us to kind of state the general idea here. If I want to take the derivative of this composition of functions, f of g of x, then what I do is I take, again, this derivative of y, this derivative of f, so f prime, but with respect to u, which is this inner function. So it's f prime taken at g of x times the derivative of the inner function with respect to x, so times g prime of x. And this is the chain rule. Now the general idea, because we'll start working some examples here in the next video, but the general idea of what we are meaning by or how we're going to apply the chain rule is that when we take the derivative of y, what it really is it's the derivative of the outer function and we would take that at the inner function. That's kind of what this f prime of g of x is going to represent. So we would take the derivative of whatever the outer function is, but we would keep that inner function in there. And then the part that really becomes the chain rule is we then multiply that, so times the derivative of the inner function, which is what this g prime of x is representing. And you might need to see a couple of examples, and like I said, it'll occur in the next video. But the idea is we're going to take the derivative of the outer function, and we'll take it at the inner function. So when I look at this f prime of g of x, I'll take the derivative of the outer function, but I'll leave that inner function g of x. And then after I do that, the chain rule process will say to multiply it by the derivative of the inner function, which is going to be g prime of x. So in the next video, we'll work a couple of examples, and hopefully it'll clarify some of what this chain rule is requiring you to do.